Hello, this is Evan Rogerson, and I'm MotorGang here, and today I'm going to be walking you through how to code the simple robot that I made in my last video, which if you haven't already seen, go ahead and check that out in the top right corner, as that shows you how to build this robot. Although since then I have added some of the electronics. So in this video I'll be showing you how to use text code using C++ to be able to control your robot using the controller with basic drive controls. And in one of my future videos, I'll be going through and explaining how to do some more autonomous coding on this, so be sure to subscribe so you don't miss it, and like and comment in order to please the YouTube algorithm. In order to start, we need to download our coding environment. So here up in the search bar I've typed in VexCode V5 Pro download. Then we're going to go ahead and click on the top link, and we're going to download this here. This isn't the IDE that everybody uses, but I prefer this over the new Visual Studio thing. I do not like Visual Studio. Now when you open this up, it is not the first one, VexCode. I like to use VexCode V5 Pro, and that's what this tutorial will be going over. So you're going to go ahead and download that. So once you've finished using the wizard to install the program, and again, if you're on a school computer, you're probably going to need your administrator's help with that in order to be able to do that. But once the program's installed, it should open up to something like this, except you probably won't have anything in recents. So we're going to start making a brand new program. So we're going to go to File, Open Examples, and then you should see the competition template. And as per one of the rules in the game manual, you're required to use this for all of your competition code. Name it something. You are not allowed to have any spaces, so you can potentially use dashes if you want, but you can't use any spaces. So we'll go ahead and create that program. Now it's going to open up to this. So assuming you have no knowledge of any coding, this is going to look quite a bit confusing. So all of this dark green stuff is what's called comments, and these are lines of code that the program doesn't really care about, because this is in like written text that you and I can understand. But in order for the V5 brain to understand it, the VexCode program will convert all of this into binary. However, when it converts it to binary, it doesn't actually do anything with any of the things in dark green, the comments. It just completely ignores those, skips over those. So if I were to delete everything in dark green, it doesn't actually affect any of the content of the program. However, if I delete anything that's not in dark green, then I can be affecting the program. So in order to comment something out, in order to just comment out a single line of code, we just do 2 slashes like that. So you can see 2 slashes. This is a comment, and that's just one line, so the next line will be normal code. Additionally, you can do a multi-line comment, which is a slash and then a forward, and then you can go this is a comment, and you'll notice everything after that immediately got turned into comment, and then we'll do another asterisk and another slash, and it will go back to being normal code. Comments are really important for a bunch of different reasons. First of all, they help you understand the program, because once it starts to get more complicated, it can be harder to understand the flow of what the program is actually doing. Additionally, if somebody else were to go and look at your code, then they need comments to understand it, because variable names and stuff, it might be a little bit confusing for them if they don't know what's going on. And it's going to be a requirement if you ever do any job for coding. And it's also relevant to judging for certain judged awards, even just within Vex Robotics. So it's really important that you get in the habit of commenting your code. So as you can see, the comments are kind of telling you what this is. This is the pre-autonomous function. So that's all of your code that's going to run before the match starts. Now this is the autonomous. This is what your autonomous code will be. This is your driver control code. And then this is just some of the competition stuff, so you don't need to worry about messing with this. So let's just write a little comment there. And you can also go over and collapse these with these little plus and minus boxes over here. In C++, in order to like nest things inside of them, they use brackets. So these little curly braces are what we use to denote, like, the autonomous code will be in between that curly brace and that curly brace down there. You can see when I click next to them, it kind of highlights the two to show that those are a pair. And anything in here will run during autonomous. And anything outside of there will not run during autonomous. All right, so let's move up to the beginning and kind of go through and explain what the program is doing. So first of all, this is including vex.h. So when you download the program, it's also going to download a file called vex.h. And just like you have .pdf files and .exe files, you also have .h files. And these are header files, and they contain information that is relevant to the program in order to know how to properly operate. So this is going to contain the library of all the VEX functions. So when the VEX engineers go and they figure out how the brain is going to interface with the code, all of the code that runs on the brain and how to easily use it is inside vex.h. So instead of manually doing lower level memory management on the brain, you can just create a motor and the brain will already know what a motor is because of this. So let's just comment that as the vex library. Now, this is using namespace vex, which essentially allows the program to assume that anytime you're not specifically stating something, it's from the vex library. So competition isn't something in normal C++. So by using namespace vex, it knows that it's from the vex competition. Otherwise, you would have to do vex and then 2 colons. If you want to do that, go ahead, but I'm going to leave this code in here, since typically within a vex program, you're not going to be dealing with a bunch of outside libraries. Now, next up, you can see that this little light blue, that has to do with classes, which is how the structure of C++ is set up. This is essentially telling it to create a competition, and that is of type competition. The variable naming is a little bit confusing. C++ is case sensitive, so capital C competition is different than lowercase c competition. Now, this is just the name. We could change that to anything, and as long as we change it in the other places in the program that it references competition, you can see when I go to the errors, it says competition, it doesn't recognize those, but if I were to go and change those to random, now the program's going to go back to being happy. But like I said, you're not going to have to mess with that, so you can just know that it's creating the competition so that the program knows to reference field control. Now moving on to the pre-autonomous, you can see this is it, and pre-auto is going to be your thing initialized in the vex library, and then void essentially means nothing in C++, so this means that it's taking in nothing and it's outputting nothing, because your pre-autonomous function, it doesn't need to specifically output anything back to the program, it just needs to do certain things with your sensors and stuff. So this is what's called a function, which are a good way to organize your programs. If you're doing something often, essentially, it would be like if I could just run the function bake a cake, and I could tell you to go bake a cake. And then previously, I've told you to go bake a cake, you need to grab some eggs, grab some flour, mix them together, and do all these different steps. But instead of telling you whenever I want you to bake a cake, I like grab the eggs, grab the flour. Instead of telling you that every single time I need the cake baked, I can just say bake a cake because I've already defined what bake a cake means. And in this case, that's what pre-auto is. Or something is quite large and you want to easily be able to call it, it's defining what the pre-autonomous routine already is. It makes it easier to break down the program because you know that this is where you're just defining what the pre-autonomous does. This is a similar setup with autonomous. It's a function and it doesn't take in or return anything. But instead of having to define autonomous when it's used, you can put it out here so it's much easier to be able to quickly find autonomous and reference it. Now, user control is a similar setup. However, it is something different. This is a while loop. So you can see there's multiple sets of nesting braces in here. So this curly brace corresponds to that curly brace, and this curly brace corresponds to that curly brace. And it's good practice to indent your code. So you can kind of see that line right there and that line right there to show which curly brace is matching with which curly brace. Now, inside this while statement is what's called a conditional. So conditionals are binary statements. It's something that's either true or something that's false. So I could put if 5 is greater than 3 in there, and that's always going to evaluate to true. And the while loop, what that does is as long as this statement is true, it's going to continuously run the code between these curly brackets, and it's just going to run it all the way until that statement is no longer true. So when you put something like while true, or in binary, 1 is true. So when we just put 1 in there, that means it's always going to run this code, and it's just going to keep running it. So this is where you're going to put your things like driver input. So like when you move the joysticks, you always want the robot to be responding to your joysticks. So that's going to be in here. And now at the bottom here, we have a wait command, which is going to wait for 20 milliseconds, which is a thousandth of a second. And that's just so the brain isn't constantly thinking, because computers are really, really fast. So instead of using up all of the memory on your brain by constantly running it, this is going to be about a 50th of a second. So enough that you're not going to notice the difference of the computer waiting a 50th of a second to respond. There's going to be much larger delays that are going to cause that, mostly mechanical. So now going up to the top, we can start writing some code. So we're going to start by going here, and we're going to define our instances of motors and other devices. So to start off with, we're going to define what our controller is. So similar to the competition, we're going to call the class controller, which essentially tells the code that we are making a controller. Also, be sure to turn on enable expert autocomplete. That way your things will autocomplete. So you can see here when I was typing in motor, now if I just start typing, it'll automatically fill into motor, which makes it easier so you don't have to memorize all of the syntax. Then within here, we're going to name the controller. For this, I'm going to name it controller1. And you can name your variables almost anything you want. The only things that you can't name them are what are called reserved keywords. So I couldn't name it something like pre-auton because pre-auton is already set to something. So that's going to cause issues because then when you just call what pre-auton is, it's not going to know which one you're referring to. Or I couldn't name my variable autonomous. That would cause issues. But anything that isn't already reserved, I can call. Additionally, there are some restrictions. You can't use spaces in your variable because then C++ thinks that control is the name of your variable and it doesn't know what ler1 means. Finally, it's also going to complain, I believe, if you put numbers in front of your variables, they need to start with letters. Now that we've said controller, we need to tell it what it is. In C++, the equals sign means that you're setting something to a value. It doesn't mean that the two things are the same. So we're telling the controller that it is a controller. Very advanced code. And then the parentheses, you'll kind of see there, that's where we would tell it specific details about the controller. However, controllers are just controllers, so there's no specific things there. You'll see that more when we get onto the motors. Then because it's C++, we need to put a semicolon at the end. And that kind of functions as the same as a period in English. It tells you that this is the end of our statement. That's the end of our statement. And now that this is written, let's go ahead and comment that line to tell it what it is. So we are creating a controller. Next, let's go on and create all of our motors. So let's just write a comment. We're going to create motors. So similar syntax for that, we're going to start by describing it as a motor, and then we're going to name it. So on the robot specifically that I have here, I have 6 drive motors, and I have 1 random motor on top that I just put there to show you guys. So to start off with, since variables can't have spaces, you want your variable names to be very clear about what you're referring to. So I'm going to call this one left front. And again, we can't have spaces, so in order to show that they're different, I'm going to use a capital F. This is what's called camel case. Additionally, some people like to use snake case, which is like that, just to kind of show as the white space. But this is what I prefer to use, so I'll be using that here. And then we need to use the similar syntax if we need to tell it what it is. So that's a motor. Now you can hear we're passing parameters into the motor to tell it specific information about the motor type. So the first parameter that we need to pass in is the motor's port number. So this robot is set to have its front left motor in port number 15. So the syntax for that is all capitals, port 15. Now we need to tell it what type of motor it is. So this is a green motor. So the internal cartridges on the motors, since the motors spin at 3,600 RPM, especially if you competed in spin up, you'll remember that because people ran motors without cartridges at all. Now it's illegal. So the blue motors, since 600 RPM is 1/6 of 3,600 RPM, we would put 6 to 1. And green motors are going to be 18 to 1. So ratio 18 to 1. And then red motors, you would do 36 to 1 there. Now, we need to tell it whether or not the motor needs to be reversed. So when we go and look at our front left motor, we can see that when the motor spins in the positive direction, its wheel goes backwards. So just to make it easier for us, we want to put true. So it's asking the question, is the motor reversed? And we are going to say, yes, this is true. Now we're going to go ahead and do these for the other motors. So we're going to write out motor is the name. Then this is the middle left motor, so left mid. And that is a motor. That is plugged into port 13. That is still a blue motor. And this one will, and now we can go and look at this one, and we can see that when we spin this one forward, the wheel spins forward, so it does not need to be reversed. Oh, and it looks like I have a small spelling error there. So all your errors will be highlighted in red, and you can also go to the problems tab to see more specific details. Like if I were to forget the semicolon right there, you can see problems, it expected a semicolon, and it'll tell you the line number, 28, and it would be the 49th column over. So then we can go there and we can add a semicolon. Sometimes the errors will be a little bit harder, and those are just syntax errors, not logic errors, which are much harder to find. Now I'm going to go through and complete these for the rest of the motors. Alright, so now that that's done, let's go ahead and make it clear that these are the drive motors. Now let's go ahead and create that last motor. Alright, so now we have that motor created. Also get in the habit of constantly pressing Ctrl S, that way you can save your project. Because you're always going to want to have it saved. Now, since we're not using a Mecanum or xDrive, all of the motors on the left side of the drivetrain should be doing the exact same thing at the exact same time, and the same goes for the ones on the right side of the drivetrain. So now we're going to create motor groups. So we can essentially just call these motors all at once, and it'll move all of the motors by calling just one object. So we're going to create a motor group. And now this is really easy to do. We can just put the name of our motor group that we want, and then we're going to put in parentheses as parameters all of the motors that we want to pass in. And that's the motor group created. Now I'm going to repeat that for the right side. Alright, now we can move on to the user control period. Now that we have all of our motors and our controller set up, we can go all the way down to the user control period. So since we want this code to be repeated, we're going to put it right in here. And any of your code that you don't want repeated, like maybe if you want to set the stop types to different values, then we can put those up here. So the basic command that we're going to be using here is .spin, which is going to tell the motor to spin based on some certain parameters we pass into it. So we can start here by going to left drive, and we're going to press dot and then spin. And when we autofill it, it's going to tell us what type of things that we need to do with it. So we're not going to deal with reversing the motors here because we already did those up here. So we can just tell these motors to spin forward. Now we need to give the velocity and the units that we're dealing with. So I would highly recommend using volts as your units, not percentage control, because that has a couple of advantages. Also, RPM is the same as percentage control, just written in a different way. Percentage control tries to get the motor to spin at a certain speed. So if you're encountering a lot of resistance, it'll give it more power, and if it doesn't have a lot of resistance, it'll give it less. But if you just use voltage control, you can actually sometimes get more power out of the motors. For example, the 600 RPM motors, by just giving them maximum power and not telling them to spin at 600 RPM, you can actually get them going over 700 RPM, assuming you have low friction. So I'd highly recommend using volt and only using percentage if you have a very specific circumstance. But I would recommend volt as the default for everything that you do. And the motors can give between -12 and 12 volts instead of the -100 to 100%, but we'll get to that later. So in order to make basic tank control, we want the left drive to respond to stick number 3, as you can see here, and we want the right drive to respond to stick number 2, as you can see there. So we're going to tell it to spin at whatever position that the stick is at. So when the stick is all the way up at position 100, then we want the motors to spin at maximum speed. So we're going to call controller 1, which is our controller that we created earlier. And then we go with axis 2, or this is the left drive, so we'll go with axis 3. And then we want its position. And we want it to use units of percent. So that will return us a value between -100 and 100. However, the voltage command takes in -12 to 12. So in order to do that, we are just simply going to multiply this by 12 and divide it by 100. And that will do the conversion for us to get this from a scale of -100 to 100 to a scale of -12 to 12. And then we'll put a semicolon because it's the end of the statement. Now we're going to repeat this code, but with the right drive and that would be using stick 2 instead now.
Alright, so as you can see here, I have the code, and up here, it's showing the little green controller and the green brain, which as you can see, I have the controller plugged into the computer, and then the controller is connected to the brain. You can see with the little radio thing up in the top right there. So now we're going to go over here, and we're going to download the code. And now you can see it's downloaded. We make sure to check that it did actually download, because sometimes it does fail. And now we can go to programs on our controller and start it. Now, if you look over at the robot, this is the left stick, so that should control the left half of the drive base. And this is the right stick, which should control the right half of the drive base. So as you can see, everything is working.
So there are still a few more things that I want to cover in this video before I wrap it up. The first of which is how to use other motors other than your drive motors and how to add those. The next one is just basic introduction to how variables can be used. And then finally, I'm going to show you how to code Arctank versus tank control, because those are two different control schemes, and which one you use depends on personal preference. I personally like arcade better. So in order to be able to write code to control another motor, first of all, since we're going to have multiple things, we should comment to make it clear what section this is. So this is drive code. Let's make that nice and clear. Now we can write our mechanism code. So as you saw, I have the little blue sprocket. It's not connected to anything. It's purely for the purposes of showing you how to code an initial mechanism. So we're going to start off by making an if statement. So if you've done any kind of coding, you'll be familiar with these. We have if, else if, and else statements. The Python equivalent is elif. So up here we have the if, and inside these parentheses we're going to have conditionals, just like we had up here in the while loop. However, if we were to put if1 in this little section, then it would always run this block of code. Then, if this block of code evaluates to false, then it'll jump down and it'll run the else if block. And if the else if block is true, then it's going to run what's in here. And if the else if thing is false, then it'll jump all the way down to the else statement. So it's going to run one of these all the time. So a classic example that if you take any coding course you'll have to do is if grade greater than 90, then we would say you have an A. If grade is greater than 80, then you have a B. And then if it's anything less, then we will say C or lower, which this is just how the basic logic would evaluate, because even though like a 95 is bigger than 80, it's never going to execute this block of code, because since it passed this first conditional statement, it's just going to skip all the way down to the bottom and skip over this last. But since we have an else statement here, one of these things will always run. Going back to what we actually want to do now is we want to use, again, the controller buttons. So controller1 dot button, and I'm going to use the bumpers. I'd recommend using the bumpers before you use any of the other buttons, just because those are easier to press. So if button 1 is pressing, so this will return true if the button is pressed, and it will return false if the button is not being pressed. So then we can tell mechanism to spin, and it will be spinning forward at 12 volts. Now, if the other button is being pressed, the one right next to R1, which is R2, then we want the mechanism to spin in reverse. So we could do reverse 12 volts, or we could do negative 12 right there. They're both going to accomplish the same thing. And then if none of these buttons are being pressed, we don't want the mechanism to move, so we're going to tell it to stop. And this is the basic way that you set up most mechanisms. It's still pretty much the exact same code that I used to run like my intake on my robot. Next, we're going to go and add arcade code. So since we're not going to be using this is tank drive code, let's make that clear. I'm going to go ahead and comment this out. So like I said at the beginning of the video, none of this code actually exists in the computer's mind now. So we're going to go and write arcade code. So arcade, you use axis 3 in order to move the robot forwards and backwards, and then you use axis 1 to turn the robot side to side. So right here, we want them both using axis 3 to spin forward. So right now, As you move axis 3 forward, the robots will spin forward, and as you pull axis 3 back, the robots will drive backwards. However, this doesn't add any way to turn. Now, purely when we're turning, when we move axis 1 to the right, we want the robot to turn to the right. So in order to do that, when you think about it, you want your right wheel spinning backwards and your left wheel spinning forwards. So we're now going to go ahead and add controller 1 axis 1 here. And then since we know that we want the right drive spinning in reverse, we're going to subtract the value of controller 1 axis 1. So now we have this basic code. Now this will give us arcade control. So let's go ahead and comment it as such. Arcade code. Now let's say you're not sure which one of these you're going to want to do, and you want to be able to easily try both of them without having to download multiple programs. So up here, we're going to go and create a variable. So there are different types of variables. We'll just be using an integer type here, which is the most basic. An integer shortens down to int. So this is going to be a variable that can store numbers without decimal places, and it can also do negatives. If you think back to your math classes, learning about like rational, irrational, whole numbers, integers, this is a certain type. You also have floats, which can do decimals, and unsigned integers, which can only be positive numbers. But for this case, integer will work, and this is the default variable type that most people will use. You don't really have to worry about which data type you're using unless you get into lower level memory management. In fact, some languages like Python don't even specifically tell you what type of variable is, which I find quite annoying. So we can name this variable drive type, just to make it obvious what it is. And we want to initialize it to something, and we're just going to set it to 0 here. And now the program's going to complain. This is a yellow error, which means that the code can still compile and it can still run. But the computer thinks that you've probably made some sort of logical error because we've created this variable, but we haven't actually used it for anything. So now let's go ahead and use it. So again, we're going to create a really simple else if statement. So here we want to set drive type. Now we're going to say if controller 1 button A is pressing and controller 1 button B is pressing. So if it's here, we're going to set the variable of drive type to be equal to 1. And now we're going to go down here and we're going to set the drive type to be equal to 2. And let's comment out what these specific things are doing. So when drive type is 1, we want to say set to arcade. And then when drive type is 2, we want to set it to tank. And this is a thing where it's very important to have comments because you're not going to know what these variable types are. You could use a more complicated variable type to store your information, but this is just going to be the easiest way to implement it code-wise. So now we're going to go up here and we're going to add another if statement. So here we have both sets of code. And we're going to add another conditional statement. So we can actually reference the value of this variable. So we can say if drive type. And in order to check if something is equivalent, like I said at the beginning of the video, the equal sign you use to set something to a specific value, which you can see that I also did up there. I set drive type to be 0. The doubles equals is in order to check if two things are equivalent, more of what you would think of when you think of the equal sign in math. So if drive type equals 2, then we want to run tank control code. So we can copy and paste our tank control code into here. And now, else if drive type equals 1, now we want to run our arcade code instead. And if you haven't pressed either A or B, the code will do nothing because unlike with the else statement at the end, that's kind of your catch-all. There is no catch-all here, and it'll just skip over both blocks of code. Now that we have this code written, let's go ahead and download it and make sure that it's all working. All right, so I've gone ahead and downloaded the code, so let's go ahead and run it. So as you can see, the motors aren't doing anything because I haven't pressed either A or B to set which arcade or tank we're using. But since the other one wasn't set to it, you can see when I press right bumper and left bumper, it makes the little thing spin. And it's kind of hard to tell on the camera frame, but it is actually spinning different directions. I guess the FPS is having a hard time picking it up. Now if you go here, you can see when we press button A, now the robot drives forwards and backwards and uses the right stick to turn. And we can even do both those at the same time. Now when we go ahead and press button B, now it moves back to tank control. So that's just a brief introduction on how to make basic code work for your robots. And again, I'll have another video coming out for how to make an autonomous code using this robot design, and we'll add a couple of sensors to it. So make sure you subscribe so you don't miss those. Thanks again for sticking around to the end, and consider joining the YouTube membership for early access to some of the videos.
Finally, I know this is a bit more of an advanced and technical topic than most of my videos cover, so please do not be afraid to comment any of your questions that you have down below, and I will be sure to respond to those. Additionally, feel free to follow along and go through and reference the code, but I will not be having a copy-pastable thing in the description because as per the code of conduct, students need to be able to understand their own code and they're not supposed to be copy-pasting their code from outside sources. But you can go through, follow along, listen to the logic, and write it out yourself.
Thanks, and I'll see you in the next one.